In this session, we will discuss about the practical questions from the content that we have discussed under the trigonometry. As the first set of questions, I will take the conversion of the degree measures into the radian measures. From this first question, I will select a set of sub questions from the parts from 1 to J, and I will discuss them now. In the first question, I will discuss the part A, part D, G, I, and J. You can try for the rest of the conversions. Therefore, if I directly go for the discussion on the answers for them, in the first question, it is asked to have the conversion. It is the angles are given in the degree measure, and we are asked to convert them into the radian measure. According to the content that we have discussed in the previous sessions, we had the theory of conversion of the or the converting degrees into radian. We have identified that 180 degrees equal to 5 radians. Uh, from that, we have obtained 1 degree is equal to 5 over 180 radians. Therefore, using that technique, we will be able to have these conversions. Now, we'll try for them. The first one is given as here what we have, what we know is for this conversion, we know that 1 degree is equal to 5 divided by 180 radians. Therefore, according to the first part of the part A, it is given as the angle equivalent to 30 degrees. Therefore, this is equal to, if you are having 1 degree as 5 over 180, then we have to multiply it with 30. Therefore, we will get this as 30 multiplied by 5 over 180, which gives the value as 5 over 6 radians. Then the next part I'm taking here is part D. It is 45 degrees. 45 degrees. Here we'll get 1 degree equals to 5 over 180. Therefore, 45, we'll get 45 multiplied by 5 over 180. If you perform this calculation, you will get this value as 5 over 4 radians. Then next question I am taking is this part G. I will take it. In here, the angle is given as 75 degrees. Then the conversion can be taken as 75 into 5 over 180. Then we'll once we solve this, then we can get this value equals to 5 times 5 divided by 12 radians. Then next one is the angle is 300 degrees. Then 300 multiplied with 5 divided by 108. Once we perform the calculation, we will get this quantity as 5 times 5 divided by 3 radians. And for the last part that I am going to discuss for the first question, the last part is part J. Here it is given as 40 degrees. 40 degrees in the sense it is 1 degree equivalent to 5 over 180 radians. Therefore, 40 degrees equal to 40 multiplied with 5 over 180. Then we'll get this value equivalent to equivalent value in radians. It is 2 times 5 divided by 9 radians. Therefore, these are the answers that we are getting For the parts that we have considered in the first question, it is asked to have the degree to radian conversion. In the second question, I would take the discussion now. The second question here, you are asked to convert or express the following angles in degree measures. The angles are now given in the radian measures. Therefore, you are asked to have the conversion or the convert these degree measured angles into this radian measured angle into degree measures. Therefore, in the second question, I will discuss the quantities, the first part, then part C would be discussed, part D, G, and G. These parts will be discussed under the second question. In the second question, it is asked for the conversion from radian measures to degree measures. According to this conversion, what we have observed was, then if you are having for this radian conversion, what we can do is radian to degree conversion. uh, Here we had 5 number of radians is equal to 180 degrees. Therefore, 1 radian was equivalent to 180 degrees divided by 5. Then we can use this conversion for the radian into degree measures. Then we'll use that concept for the conversion. In the second one, in the second question, it is asked to have the degree, the radians to degree measures. We need to have the radian and we need to convert it into degree. Then what we know is, we to have this conversion, we know that it is given as this 1 radian equals to 180 divided by 5 degrees. Then what we know is 1 radian is equal to 180 divided by 5 degrees. Now we can use this technique for this the converting of the values. First part, it is the part A, it is given as 5 divided by 3 radians. Then this can be multiplied with this quantity to convert it into the equivalent degree measure. Then 5 divided by 3 multiplied with 180 over 5 degrees. Then we can have this 5 and 5 cancel out. Then 180 with 3 cancel out with 260. The next part I will take is part C. Part C is given as 5 divided by 18 radians. Then we have to multiply 5 divided by 18 by 180 degrees divided by 5. Cancel with the cancellation of the terms, we'll get the value as 10 degrees. Then we'll take D is, it is 3 5 divided by 10 radians. Then it is 3 5 divided by 10 multiplied with 180 degrees divided by 5. Here we can see the 5 and 5 cancel out. Then 3 times 180 divided by 10, we'll get the angle as 54 degrees. Then the next part I'm going to consider is 13 5 divided by 10. Is the part G I'm going to consider. 13 5 divided by 10 radians. Then this can be considered as 13 5 divided by 10 multiplied with 180 divided by 5. Here also we can see that 5 will be cancelled out. Then the multiplication of 13 with 180 divided by 10 leads to the value as 234 degrees. Similar manner, we can continue it for the last part. It is the part J. It is 11 times 5 divided by 6 radians. Then we can get it as 11 times 5 divided by 6 multiplied with 180 divided by 5. Here also, once the terms are cancelled out, then we will get the value as 330 degrees. Here we have discussed about how we can convert the radian measures into the degree measures. Now we will discuss on another the theoretical quantity which is used to find the length of an arc and the area of a sector. Suppose that if we have get a circle in this form. Now suppose that if you are having the circle in this way, suppose that this is the circle we are considering, and here we'll consider this as the center of the circle. If you are considering this as the center of the circle, and now generally we are taking the zero in this line, on this line. This is the angle 0 we are considering, and if you are measuring an angle in the positive direction, and here we will consider this angle is supposed to be theta. Suppose that this is the angle theta we have measured, and now what we can consider is, here we can consider that if this is the center O, if this point is A and if this point is B, then we can consider that AB is the arc. AB is the arc formed by the angle theta, or the angle theta subtends at the center the arc AB is formed. Now, if you need to find out the length of this arc, if you need to find out the length of this arc, what we need to do is we need to find the length of AB. This is not a straight, we cannot say it is a straight line, therefore we can it is quite a curve, therefore we are saying this AB as the arc created by the subtending in the angle theta in the center of this circle. Therefore, we can find the length of the arc AB, or the length of AB can be taken as r times theta, where r is the radius of the circle that we are considering, and the theta is the angle subtend in the center of the circle, which has created this AB arc. And when we are using this equation to find out the length of an arc, what we have to keep in our mind is we have to keep theta in radian measures. Theta has to be always used in radian measures if you are using this equation to find out the length of the arc AB. Using the equation AB equals r theta, the length AB equals r times theta, where r is the radius of the circle and theta is supposed to be the angle subtending in the center of the circle. And the next thing is, if we are having the arc, now we can see that if you are considering about the quantity or the area A or B, the area A or B supposed to be named as the sector. Therefore, we can, if it is a sector, if it is an arc, we can find out the length. But if it is a sector, we have to find the area of that as well. Therefore, we can say the area of the sector. To find out the area of the sector, what we can use is we can say the area of AOB. The area of AOB can taken as half times r squared times theta, where r is the radius of the circle and theta is the angle obtained in the center of the circle to create this sector AOB. Here also we have to make sure that theta is in radian measures. Otherwise, if it is given in the degree measures, when you are substituting it in the angle, you have to convert it into the radian measures, and thereafter we can continue the calculation. Now we will focus on some examples related to finding the length of an arc on the area of the sector. Suppose this is if I am arbitrary take a value, suppose that this is the circle we are having, and if it is created the arc and the sector as AOB. Suppose that this is the angle O, the points A, O, and B. And suppose that this is the angle we are having as it is 36 degrees. Suppose that this angle is 36 degrees, and you are asked to find out the length of AB and the area of the sector AOB. In this regard, what we need to do is we need to first find out the length AB. To find out the length AB, what we can do is we can use the equation. To find out AB, we can use the length r theta. Here I have missed the radius. If it is given as 3, or the units as 3 centimeters, I will take the unit in centimeters. Therefore, we can take the AB, the length of the AB arc can be considered as r is equal to 3, and then theta is 36 degrees. 36 degrees, first we need to convert this 36 degrees into radian measures, equivalent radian measures. Then what we can do is we can say 36 multiplied with 5 over 180, use the radian measure which is equivalent to 36 degrees. Therefore, if you perform this calculation, we will get this as 5 divided by 5. Now we can substitute the radian measure equivalent to angle 36, the degree 36, the angle having the 36 degrees. Therefore, we can have the 36 degrees equal to 5 divided by 5. Therefore, we can take the AB length is equal to 3 times 5 divided by 5. Now, if you need, you can have this substitution for 5, where we are taking the 5 is equal to 3.142. We will consider, if it is considered, we are approximating the value of 5 to 3.142. Then we can consider the length of this arc is 3 into 3 times 142 divided by 5, and this leads to the value as 1.885. And here we have to now show it the units that it is measured. Since the length is measured in centimeters, this will be also given in the length as the centimeters as well. Therefore, this is how we are calculating the length of the arc. In the similar manner, we can have the calculation for area of the sector as well. To find out the area of the sector, what we have to do is we have to use the equation half times r squared times theta. AOB sector, area of the AOB sector, we can use half times r squared theta. Theta has to be again kept in the radian measures. Then we can use it as half times r squared. It is 3 squared is used. Then theta has to be kept in radian measures. It is 5 divided by 5. And we need to perform the calculation. If you have the values altogether, we'll get this as 3 squared. It is 9 times 5 divided by 2 times 5, it is 10. And if you consider, or if you approximate the value of 5 to 3.142, we'll get this quantity as 9 times 3.142 divided by 10, which equals to 2.8278. Here we can include the units as well. Since we have measured the length in the centimeters, we can consider the area as the squared centimeters. Therefore, we can get the area of the sector as 2.8278 squared centimeters. This is how we are using the equations to find out the length of an arc and the area of a sector. And here we will discuss some examples related to finding out the length of the arc and the area of the sector. Here we are trying to find out if some of these according to the equations, if the length is given, length and radius is given, how to find the angle theta. If the angle and the length is given, how to find the radius. Likewise, there are some examples included under the third question, and here I will discuss the first three questions. Uh, the first four questions will be discussed of obtaining the answers for this set. Now we will have the discussion on these parts one by one. Here it is given as if r is equal to 15 centimeters and theta is given as 3 5 over 5 radians, we are asked to find the L and S, where L is defined as the length of the arc of the AB circle having the radius r, and r is given, and theta is the angle subtending an angle theta at the center. Therefore, S is supposed to be the area of the sector. Therefore, simply it is given as L and S. It is the length of the arc, and S is supposed to be the area of the circle. Therefore, as a general picture, if I draw it for the third one, for the discussion for the third question, it is quite the can have the circle, and if you mark down the length accordingly, here we are having the center O is considered, and they have considered the points as A and B. Then angle theta is considered, and the length of AB was considered as L, and the area was considered as S. To have the length, we can have the equation L equals, if it is R, it is R times theta, and S can be considered as half times R squared times theta. Therefore, these are the quantities or the equations that we can have if we are having the length, area, angle, and the radius of the circle. Therefore, if I take the part A, here it is given as value of r is equal to 15 centimeters, and value of theta is given as 3 pi over 5 radians, and we are asked to find out value of L and the value of S. To find the value of L, what we can use is we can use the equation L equals R times theta. Value of R is equal to 15 and value of theta is equal to 3 times 5 divided 5 by 5. Therefore, if you solve this, you will altogether get this as 9 times 5. And if we need, we can substitute the value of 5 equals 3.142. Since L is, or the radius is given in the units as centimeters, we can have this is equal to 9 times 5 centimeter. And as the next point, we are asked to find out the area. It is the value for S. S can be taken by the equation half times r squared times theta. Then S is the value of S is needed to be calculated. Value half, then r is equal to 15. Then we have to consider 15 squared, then multiplied with 3 times 5 divided by 5. If you perform this calculation, then we'll get the value as 135 times 5 divided by 2, and here we are considering the units as square centimeters. But if you need, we can have the substitution of 5 where 5 equals to 3.142. If we need, we can have that approximation as well. And I will take the next part. It is the part B. In the part B, the values are given for r and theta. R is given as 20 centimeters and theta is given as 110 degrees. Since the theta is given in the degree measure, first we need to have the degree measure into radians. Degree to radian calculation must be there. Therefore, we can say 110 degrees equivalent to multiplied with 5 over 180. Here we will get the value which is the degree or the radian, which a radian measure which is equal to 110 degrees. It is 11 times 5 divided by 18 radians. Therefore, now we can have or have the substitution. Here also we are asked to find out the value of L and the value of S. These are the values we need to find out. As the first point, we will try to find out the value of L. L can be taken as where L is equal to R times theta. R is equal to 20 and theta is now given as 11 times 5 divided by 18. Once we have this calculation, 20 times 11 times 5 divided by 18. Altogether we will get it as 110 times 5 divided by 9 centimeters. Since the length is asked, we can take the length as 110 times 5 over 9. Using the equation to calculate the area of the sector, S can be taken as half times r squared theta. Using the suitable substitution, we can have half times r is 20 squared, theta is equal to 11 times 5 over 18, and this leads to the value 20 squared multiplied with 11 times 5 divided by 18 divided by 2 leads to the value as 1100 times 5 divided by 9 square centimeters. Therefore, this is the area of the sector that we are getting for the values of r equals theta, r equals 20 and theta equals 110 degrees. Now we will have it for the part C as well. In the part C, the values that they have given for us r is equal to 18 centimeters, and what we know is L is equal to 21. L is equal to 21 centimeters. Therefore, now we are asked to find out the value of theta, and we need to find out the value of S as well. To find out the value of theta, we can simply use the equation used to find out the value of L. It is because now we know the value of L and R. Therefore, we can use the equation L equals R times theta to find out the value of theta. And please keep in your mind that using this equation we are getting the angle in the radian measures. But if you need to convert it into degrees, use the appropriate conversion technique. Here value of L is equal to 21 and the value of R is equal to 18, and then the value of theta is needed to calculate. Therefore, using the substitution, we will get the value of theta is equal to 21 divided by 18, which can be keep as a fraction 7 over 6, and here we are having this as the radians. But rather than keeping this as the radians, if you wish to convert it into the degree measure, what you can use is 7 over 6 times radian. The 7 divided by 6 radians is equal to 7 divided by 6 multiplied with 180 degrees divided by 5. Using this conversion, we can have the value. Here, if you substitute the value of 5 plus 3.142, then we'll get the answer as we'll get the answer. It is 66.83. If you round it off to a whole value, then we can get this as we cannot keep this way the decimals in the degree measures. Therefore, if you are just rounding this into a whole value, then we can say this is equal to 67 degrees. Therefore, the degree measure equivalent, or the degree value equivalent to 7 over 6 radian is equal to 67 degrees. Therefore, if you only need to have this conversion, you can have it. Otherwise, this quantity is quite enough. It is because we are using the value, we are using the theta in the radian measures in the equation as well. In the next point, what we need to do is we are asked to find out the value of S. To obtain the value of S, what we can use is S is equal to half times R squared theta. Once you do the substitution, half times R is equal to 18 squared is used. Then instead of theta, now we can directly use the value 7 over 6. It is because we have identified that value in the radian measures. Therefore, once we perform the calculation, then we will get S is equal to 189. Since the units or the lengths are measured in the centimeters, we can take it is equal to squared centimeters. It is altogether 189 squared centimeters. In the next part, in the part D, it is considered that value of R is given, it is 20 centimeters. Then value of S is given, it is equal to 240 square centimeters. Then you are asked to find out the angle theta, and we are asked to find out the angle theta and the value of L. Here we can use the equation which combines the terms as r and theta, finding out the area of the sector. Here it is given as S equals r half times r squared times theta. Value of S is given as 240. Then it is equal to half times r is equal to 20. Then 20 squared is taken. Then times theta. If you perform the calculation and obtain the value for theta, you have to solve it as 240 multiplied with 2 divided by 20 squared. This leads to the value of theta given in the radian measures. Here we will get it as 6 divided by 5 radians. We can keep it in the radian, but if you need, you can convert it into the degree measures if you wish to have that value. But here I will just take the angle of theta in the radian measures, since the radian measures are used in the furthermore calculations as well. Then we are asked to find the value of L. L can be obtained using the equation r times theta. The value of r is equal to 20 and the value of theta is equal to 6 over 5, which is already obtained in the radian measures. Therefore, once we perform the calculation, we will get this as 24 centimeters. Therefore, using this equation, we can simply calculate the value for the length of the arc. And now I will discuss the use of this finding out the length of uh, length of an arc as well as the area of a sector. Then the fourth question is totally based on those concepts. Therefore, now we can discuss on the fourth question. In this question, it is saying that a thin wire having the length as 24 centimeters is formed of a shape as a sector of a circle having the radius of 8 centimeters, and we are asked to find the area of the sector. Okay, now we'll try to figure out this question first. In this question, it says that they are, they are having a wire which is having the length of 24 centimeters, and they have bent this wire and formed the new shape which is having as a sector. Therefore, if you consider about this sector, this given as the sector is somewhat like this, and they are saying that this sector it is given in the radius of 8 centimeter. Therefore, this length has to be equal to 8 centimeter. If this is 8 centimeter, then this should be also equal to 8 centimeters. It is because both of them are the radius of the circle, and here still we do not know what is the angle theta, but what we know is the length of the arc can be simply find out. It is because we know that altogether or the sector is formed from this entire wire. The length of the entire wire is 24, but already 16 centimeters were used as two radius. Therefore, if you consider about this as the length AB, the length AB should be equal to 8 centimeter. It is because the addition of these three lengths should be equal to 24 centimeters. It is simply obtained as 24 minus 8 equals to the length of AB as 8 centimeters. Now what we need to do is we are asked to find out the area of the sector. If we name the area of the sector as S, we need to find the area of the sector. It is S equals half times r squared theta. But what we know is we know the value of r. We know that value of r is equal to 8 centimeter. But still we do not know what is the value of theta. Without knowing the value of theta, we may not be able to find out the value of s. To find out the value of theta, the information that we are having is the length of the arc. Then if you are using the equation to obtain the length of the arc, L equals r times theta, then we can get the length is equal to 8, r is equal to 8, and in this manner we can find out the value of theta is equal to 1 radian. Now we can substitute it in the equation. Once we have the substitution, it is half times r squared times theta, half times r squared times theta. Value of r is equal to 8, is 8 squared. Theta is now equal to 1. Therefore, we can have this calculation. Once you have the calculation, we may be able to get the answer for this as 32 squared centimeters. Therefore, we can have the area of the sector formed by this wire is equal to 32 squared centimeters. Now we will discuss the question number 5. It is somewhat similar to the question that we have discussed previously as well. Use of the equations L equals r theta and S equals half times r square times theta will be also used in the question number 5. In this question, it says that the length of an arc of a circle which subtends an angle of 40 degrees at the center of the circle is 13.4 centimeters, and we are asked to find out the radius of the first of the circle in the first part, and then we are asked to find out the area of the sector formed by the given arc, and we are asked to consider it is equal to the value of phi is equal to 3.142. Now we'll just figure it out, the information that they have provided for us. In the question number 5, it is given as the length of angle is 40 degrees, arc is formed, and it says that this as well. This is the circle we are having using the angle 40, and arc has formed. Now we can see the angle is 40 degrees, and if you name the arc as A or B, and the next thing they say that the length of the arc is given, it is simply the AB distance, or which is equal to L, then it is given as 13.4 centimeters. The length of the arc is given. In the first part we are asked to find out the radius of this circle. Since the radius is unknown, we'll take the radius as r. In the first part, we can use the equation L times r theta. 13.4 value of r it is needed to be calculated, and now we need to find out the value of theta. But the value of theta is given, but it is in the form of the degree. Then we need to convert the degree measure into the radians first. To have this conversion, we can say this 40 degrees equal to 5 divided by 180 degrees. Once we perform this calculation, we will get the value of 40 degrees, or the value equivalent to 40 degrees. The radian measures, it is equal to 2 times 5 divided by 9. Then we can substitute that value. Here it is 2 times 5 divided by 9, and using this equation we can, or this calculation, we can take the value of r is equal to, it is 603 divided by 10 times. If you perform this calculation, you will get this value, and it is given that, and we asked to consider that the value of phi is equal to 3.142. If you substitute that as well, where instead of phi, if you substitute the value as 3.142, we will get the value of r is equal to 19.1915. Therefore I will keep it into accurate one decimal place. Then we can take it as 19.2 centimeters. In the second part of this question, it is the first part, it is the question part A, and the part B, it says that it asks us to find out the area of the sector formed by the given R. If you name the area as S, S can be taken by using the equation half times R squared theta. This is equal to half times R is, now we have found it as 19.2. Then we need to take the value of as 19.2 squared, and we have already found that value of theta is equal to 2 times 5 over 9. Here we can directly use the value of phi equals to 3.142. Then using that substitution as well, we will get this answer. It is 19.2 squared. Then multiply with 2 times 5. Instead of 5 we can use 3.142. Then divide it by 18. Use the value as 128.6963. Here also we can, if you approximate this to one decimal place, we can take this value as 128.7. Since the length is given with the centimeters, we can take the units as square centimeters. We'll move for the discussion of the next question. I am not going to take the 6th, 7th, and 8th questions at this time, since all these questions are based on the same concept that we have discussed previously using two equations. And now I will directly move for the discussion of the question number 9. Now I will move for the discussion of question number 9. Now we will discuss about the express. Here the ninth question is given as express the sine, cosine and tangent of the following angles in terms of sine, cosine and tangent of the acute angles. Here some obtuse angles are given for us, measuring in the clockwise direction and the anti-clockwise direction, having these positive and negative signs. Then we are asked to find out the equivalent acute angle for the angles given in this question. Therefore, if we just have a quick look regarding the associate acute angles, we had the associate acute angles in this 180 minus alpha, 180 plus alpha. Thereafter, we had the quick look on the 360 plus alpha, and we have not discussed about 360 minus alpha, since it is again equivalent to minus alpha. Therefore, using these concepts, now we are asked to find out the associate acute angles, as well as we are asked to write them uh, in the terms of sine, cosine, or the values of sine, cosine and tangent of these acute angles. Now we will move for the discussion of that example as well, exercise as well. Question number 9 says us, the question number 9, we are asked to express the sine, cosine and the tangent of the given obtuse angles in terms of the associate acute angles. Therefore, if we refresh our mind regarding the associate acute angles, here we will, if we are having the circle in this form, and we had the four quadrants in this way, we had the four quadrants, and we have named them as the quadrant number one, or the first quadrant, second quadrant, third quadrant and the fourth quadrant. Now suppose this is the baseline we have considered as the 0 degrees or the 0 radians. Therefore, what we have learned was, or discussed in the previous sessions was, if you are measuring the angle in the anti-clockwise direction, then we have or we had the angle having a positive sign. But if you measure the angle in the clockwise direction, we have named the angle using a negative sign. And using the concept of the acute angles, what we have observed was, here we just need to measure the angle if it is in the second quadrant. Suppose that this is the angle that we have measured. If this is the angle theta that we have measured, then the associate acute angle can be considered as 180 minus alpha. It is simply, we can say, this is the associate acute angle for this theta. Therefore, this, instead of angle theta, we can place this angle theta as 180 degrees minus alpha, where alpha is the associate acute angle if it is in the second quadrant. Now, if you have this with the those, if it is in the quadrant number 2, we had this theta equals, or the associate acute angle is alpha. Then if you consider about the value in the third quadrant. If I again write down the value in the quadrant 2, it was identified in the Q2. Theta was equal to 180 degrees minus alpha. Now suppose that if you have obtained the angle in the third quadrant, what we are measuring as the angle theta. From 0, we are measuring the angle theta. Therefore, the associate acute angle can be considered as alpha, and this alpha can be obtained, or this theta can be now obtained as 180 degrees plus alpha. Therefore, if you are having an angle in the third quadrant, what you can consider is the angle in the third quadrant can be, say, if it is theta, it can be considered as 180 degrees plus the acute angle alpha. And if it is in the fourth quadrant, here we are not going to consider it that much. It is because if it is in the fourth quadrant, what we can see is, if it is in the fourth quadrant, you may have the value of theta. We may have the value of theta in this way, but the associate acute angle is alpha. Therefore, rather than taking this as 360 minus alpha, we can simply measure this as minus alpha. Therefore, in this situation, we can say this as simply the minus alpha without taking 360 degrees minus alpha. Therefore, if it is in the fourth quadrant, then we can take this theta is equal to 360 degrees minus alpha. Instead of using this, we tend to tell this as minus alpha. It is because we are just measure the angle in the anti-clockwise direction. Rather than measuring the obtuse angle, we can simply measure the acute angle in the anti-clockwise direction. That is why we got this as minus alpha. Then if it is now if you are completed the first round, and if the angle is again coming back to the first quadrant, then we can find out if we are measuring the angle in this form. Now suppose that you are measuring the angle in this way. Now you have completed 360. Therefore, if this is the angle, then we can say this is the associate acute angle for this theta. Therefore, it can be simply written as, if it is in the quadrant 1 again, then this theta can be considered as 360 degrees plus alpha. Therefore, again 360 plus alpha, again we can say this is equal to plus alpha. It is no need to again consider about alpha. It is because now we have completed one round, and always in the first quadrant we are getting the acute angles only. Therefore, even though if we are completed, again we are getting this as plus alpha. Now we will see what we can what we have to discuss under the question number 9. In the first part, we are asked to find out the value of 350 degrees. Here we are asked to find out the value of sine of 253, then cosine of 253, and tangent of 253. This is what they are asking us to find out. Therefore, we can simply say 253. If you find out 253 degrees, this is actually if we are measuring it from here, then 253 will be in the third quadrant. Therefore, if you measure the angle, then this should be 253 degrees. Therefore, we can take this 253 is, this is the associate acute angle alpha. Then this can be taken as 180 plus alpha. Instead of 253 degrees, we can say it is equal to 180 plus alpha, where alpha is equal to 73 degrees. Therefore, addition of these two angles again construct the value as 253. But if you see about the angles in the third quadrant, for the angles in the third quadrant, what we can take is, if it is in the third quadrant, what we know is, if you are having this in the third quadrant, if it is given as sine theta, it will be written as minus times sine alpha. If you are using theta equals 180 plus alpha, then we can take cosine is equal to minus cosine alpha, and tangent theta is equal to tangent alpha. And this is also combined with the quadrant rule that we have discussed. In the first quadrant, we are having all three functions having positive. Then in the second quadrant, sine will be positive. Here, tangent will be positive, and fourth quadrant, cosine will be positive. Therefore, in this scenario, what we can take is sine 253 degrees. We have find out the associate acute angle where alpha is equal to 73 degrees. Then we can say the equivalent angle is sine 73 degrees. But once this alpha is formed in the third quadrant, the sine value should be negative. Therefore, instead of calculating sine 253, we can say that this would be equal to the associate acute angle, sine value of associate acute angle 73 degrees, but it should multiply it with negative sign, since sine function or the sine ratio is having the negative value in the third quadrant. In the similar manner, we can take associate acute angle for this cosine. Then we can get this as cosine 73 degrees, and here we are getting it as also minus. Then tangent 253, this will be equals to tan 73, since tangent is having the positive value in the third quadrant. And if you calculate the next value, it is for the uh, part B. Part B, we are having the value as, value is given in the degree measures. In the degree measure, value is given as 437 degrees. If you measure this angle, we know that if it is from the angle 0, if you are measure, then completion of one cycle is 360. Then this can be formed as, here it is 360, but once you subtract the quantity, the remaining would be 437 minus 360 degrees. Therefore, we can get this quantity as 77 degrees. Therefore, the remaining quantity should be 77. It is less than 90. Therefore, we will get 437 in the first quadrant. Therefore, we can take 360 plus 77 degrees. Therefore, we can take this as the value as alpha, and here we are taking this is the angle theta. Therefore, 437 degrees can be written as 360 degrees plus 77 degrees, where 437 it is mentioned as theta and 77 mentioned as alpha. Now this falls into the first quadrant. Therefore, in the first quadrant, what we know is, in the first quadrant all are having the positive sign. Therefore, we can simply say, in the first quadrant, we can simply say this Sine theta is equal to the associate acute angle alpha. Cosine theta is also equal to the cosine alpha. Tangent theta is equal to tangent alpha. Therefore, we can say the values of sine 437 degrees equal to sine associate acute angle is 77. Then cosine 437, it is equal to cosine 77, and tangent 437 is equal to tangent 77. Therefore, these are the associate acute angles in terms of sine, cosine, and tangent of the angle 437 degrees. Now, if it is more for the part C, in the part C, it says that the angle is given as 675 degrees. 675 degrees. First, we need to find out where this lies. Then, if you measure one round, it is 360 degrees. Then remaining would be 675. It is the degree measure we are having. Then we once you subtract 360 from 675, we are getting the angle having 315 degrees. But if it is mentioned as 350, then again it will come up to this point. Therefore, we can say this the entire angle is this 675. It is in the quadrant number 4. Therefore, we need to find out the associate acute angle alpha. This associate acute angle can be taken as this 315 can be taken as 360 minus 45 degrees. Therefore, associate acute angle would be now equal to alpha, it is 45 degrees. Then in the fourth quadrant, we can find out the values. Sine theta, it will become minus sine theta, sine minus sine alpha. Cosine theta equals to cosine alpha, since cosine function gets the positive value in the fourth quadrant. Then the tangent theta becomes minus tan alpha. Therefore, using this instead of 3675, we can say it is 360 degrees plus 360 altogether two rounds. But here we have to subtract 45 degrees, since this is now we are considering as alpha. Here this would be the angle theta. Therefore, instead of taking 675 degrees obtuse angle, we can consider minus 45 as the associate acute angle. Therefore, we can have the sine 675 degrees. Sine would be minus, then it can be taken as sine minus sine 45. Cosine 675 can be written as simply it is cosine 45, since cosine having the positive value in this fourth quadrant. Then tangent 675 degrees, it is equal to minus tan 45 degrees. Therefore, this is how we are finding out the associate acute angle for the quantity. And if you measure, or if you move for the discussion of the fourth part of this, in the fourth part, it says that the value is given as the part D. The next part, we are having the angle given as minus 868 degrees. Minus in the sense the degree or the angle is measured in the anti-clockwise direction. Therefore, the angle is measured in this in the clockwise direction or the anti-clockwise direction. Therefore, if you are completing, it is altogether 360 The next round completes the 720. Therefore, we can say with the minus, in the sense we are measuring it in the negative direction. Therefore, it is minus 868 equals to minus 360 minus 360. Then we can find out the remaining quantity, the difference between 868 and 2 times 360. Then the remaining quantity would be 148. If you measure 148 degrees in this direction, then it will come up to some point like this. Therefore, if you measure the entire angle, or this the entire angle gives the value as minus 868 degrees. Therefore, here we are measuring the angle in the negative direction. Therefore, we need to find out this as the associate acute angle alpha, and now it is in the third quadrant. In the third quadrant, what we know is, in the Q3, we know that if it is sine theta, it would be in the third quadrant. We can find out that tangent will be the only positive we can have as the trigonometric ratio. Therefore, sine theta will be equals to minus sine alpha. Cosine theta would be equals to minus cosine alpha. Tangent theta would be equal to tangent alpha. Therefore, instead of taking this as minus 868 degrees, we can say this equals to this 2 times 360, but it is in the clockwise direction. That is why we are using minus. Then another the remaining part of minus 148 degrees has to be measured again. The this quantity has to be, if you are just having come entirely two rounds, and another 148 degrees in the clockwise direction. Therefore, this is the angle that we need to find out. Therefore, instead of 148, we can take, if you are measure it in this direction, we can say the associate acute angle, or instead of taking 148, we can take this equals to 180 minus 30, 100, and here we have measured this degree. It is altogether we had 720. What we taken was 868. Therefore, altogether we had minus 148. Therefore, we can simply take this with this minus 32 degrees. Therefore, alpha would be equal to 32 degrees. Therefore, we can take this 148. It is simply 180 minus 32 degrees. Therefore, this would be the angle alpha we are taking, and this would be the angle theta. Therefore, using the quadrant rule, we can find out the values. Here we can take the value of sine, it is minus 868 degrees. Then the associate acute angle was identified as 32 degrees. It is because the remaining quantity was 148 degrees. Therefore, it can be taken as 180 minus this 32 degree. Then we can take this is equal to sine 32, but we have to use the negative sign, since we are having the angle in the third quadrant. Then cosine can be taken, cosine minus 868. This can be taken as again minus cosine 32 degrees. Similar manner, tangent, it is minus 868. This can be taken as tangent 32. Therefore, these are the values that we can taken for the having the sine, cosine, and tangent of minus 868 along with the associate acute